Hello, ladies and gentlemen. Let's take a look at factored polynomials plus solutions. All right, this is the third lesson in this unit. So we're going to factor some trinomials. You have done lots of factoring already, at least you should have. If you've taken it, intermediate algebra, you did this factoring. So again, this should be review for you. If it's not, then you're going to need to really pay extra close attention. All right, here we go. So we're going to factor these polynomials. So remember, when we factor it, we're breaking it into two parts. All right, we're going to split it into two binomials. All right, so we want to know what factors of 6 will add to 5. All right. So factors of 6 that will add to 5. Well, that should be pretty straightforward. 2 and 3. 2 times 3 is 6. 2 plus 3 is 5. Okay, so our factors are x plus 2 and x plus 3. Now, we want to find the solutions. All right. Well, to find the solutions to this, we're going to take the x plus 2 and set it equal to 0. Now we're going to solve. So one of the solutions is -2. All right, we're going to take the other factor and set it equal to 0 and solve. So the other solution is -3. So we are looking for what will make that polynomial equal 0. And those are the two numbers that make it equal to 0. All right, now, if you think about this, if we were graphing this polynomial, okay, if we were graphing it, those solutions are telling us where it's crossing the x-axis, okay? So the -3 means that parabola is crossing the x-axis at -3 and the -2. So it's crossing at -2 and -3. That's what the solutions are, okay? Where does it cross the x-axis? What makes the equation equal 0? All right, let's keep going. Okay, the next one. Factors of 12, okay, that will add to -7. Well, that would be -3 and -4. -3 times -4 is 12. -3 plus -4 is -7. So the factors are x minus 3 and x minus 4. Find the solutions. Again, I would set that equal to 0 and then solve. Now, if you look at this, you really don't have to do the scratch work. Okay, we've already talked about it this year. Solutions and factors are opposites. So if the factor is negative, the solution will be positive. If the factor is positive, the solution will be negative. All right, let's keep going. Okay, the next one is no different. It's just using the letter A instead of the letter X. All right, so let's see, running out of room. Factors of -10 that add up to 3. I believe that would be +5 and -2. All right, so +5 and -2. So I'm not going to show the work here, okay? The solutions are -5 and +2. All right, let's keep going. Special factoring patterns. You have done these before. These are supposed to be easier, not harder. Okay, these are called difference of two squares. Okay, both terms are perfect squares. X squared and 9 are perfect squares. Now, we're always going to have a plus and a minus in each one. Always going to have a plus and a minus. Always going to have a plus and a minus. Okay, so these are easy. So I'm going to do, what's the square root of x squared? X. So I put x and x. What is the square root of 9? 3. I'm done. Those are the factors. Again, these are special. So my solutions are -3 and +3. Okay, the next one. Square root of 4x squared, 2x, 2x. Square root of 25, 5, 5. Now I'm going to go a little bit more detail on this one, okay? So we have 2x. I'm going to set that equal to 0. Now when I solve, I take away 5, and then I divide by 2. So my solution here is -5/2, okay? Once you see it, you don't have to show that work. Okay, see how it's set up? It becomes -5/2. Okay, let me just do it with this one too. So I'm going to add 5. And then divide by 2. So this solution is +5/2. Okay, look at it very, very carefully. And we'll just write the answer when we do the next one. Okay, here we go. Square root of that? Well, that would be 9b. 9b. Square root of that? That would be 6. And that would be 6. All right, so b is going to be -6/9. And b is going to be +6/9. But you should notice these two can be reduced. So this becomes -2/3, and this becomes +2/3. All right, again, these are special. They're supposed to be easier. Difference of two squares. Okay, the next one is also a pattern, a special factoring pattern. Okay, these are called perfect square trinomials. All right, well, what's so special about these? Well, first of all, you'll notice that the 16 is a perfect square. So the square root of 16 is 4 and 4. And the 4's add to 8. Okay, and the middle is, so it's x plus 4 and x plus 4. They're the same. Okay, they're the same. Now that could also be written as x plus 4 squared. There's only one solution to this, and that would be -4. Okay, on this next one, again, let me do this. Okay, what's special about it? Well, the square root of 81, that's 9. And I notice there's a -18 here. Well, if I add, it'll be -9 and -9, make the 18. Oh, they're the same. Again, that's why it's special. And again, this could be written as x minus 9 squared. And so again, there's only one solution, 9. Okay, well, the same goes with this next one. Again, this one's got a 9 in the front. So let's see here. So again, the square root of 25 is 5. Okay, but then we've got a 9 here. So let's see, that's 9w. Whoop, no, it's not. It's 3w. Okay, I'm trying to get it to back up. There we go. It's 3w. Okay, but whoa, the middle is 30. Okay, remember FOIL? Okay, the O and the I. The outside is 15. When I multiply 3 and 5 is 15. And the inside is also 15. 15 and 15 add up to 30. So yes, it is a special one because these two are the same. And that can be written as 3w plus 5 squared. And so the solution to that one is negative 5 over 3. All right, that's page 1. Let's go to the next page. All right. Find the value of x and the dimensions of the rectangle based on the information given. Okay, you should remember that to find the area of a rectangle, you're going to take the length times the width. Okay, so when I set this up, I'm taking the x plus 7 times the x plus 2 and setting it equal to 84. The length times width equals 84. Okay, well, again, we're going to FOIL this. So I have x squared plus 2x plus 7x plus 14. Okay, combining like terms, x squared plus 9x plus 14. Now, in order to solve this, it must be set equal to 0. So that means we need to take away 84. So x squared plus 9x minus 70 equals 0. Factor. Let's see. Factors of negative 70 that add to 9. Well, you might have to do a little bit of trial and error here. Okay. What we end up with is, I think, 14 and negative 5. Okay, let me double check that. So let's see. 14 times negative 5 is negative 7. 14 plus negative 5 is 9. So yes, I am correct. So 14, so we've got x plus 14. All right, so our two factors are 14 and negative 5. So we've got x plus 14 and x minus 5. Okay, well, let's see. So our solutions are negative 14 and positive 5. All right, well, if you think about dimensions, ladies and gentlemen, you can't have negatives. Okay, no negatives are allowed. Okay, we can't have a negative. Just not possible. So that means our x value is 5. So let's see, if I have 5 plus 7, that would be what, 12? And 5 plus 2, that would be 7. So the dimensions of this thing are 7 by 12. Let's check that. 7 by 12, yep, it's 84. Okay, so that did work out. A little bit of work to do, but we got there. Again, no negative dimensions. And our answer is 5, because that's what we were looking for. X equals 5. All right, one more. So let's say you have a rectangular garden in your backyard that measures 15 feet by 10 feet. You want to double the area of the garden by adding the same distance x to the length and width of the garden. Find the value of x and the new dimensions of the garden. Okay, we got to draw a little picture here. So we have a garden, and the dimensions of that garden are 15 by 10. All right. We want to double the garden. So I'm going to draw another one around it like this. Okay, we're going to double the garden, and we want to know, okay, it says the same distance x to the length and the width of the garden. Okay, so I don't know how much that is. I added x to the left side. I added x to the right side. I also added a length of x to the bottom and a length of x to the top. But again, I'm not sure what that x is. All right, so what else do I know? Well, since I know the dimensions of the small garden are 15 by 10, that means the area is 150 feet. Well, remember, area equals length times width. All right, well, here we go. Let's see if I can do this and make sense. I'm going to color code here. So I'm going to do the length. The length is this. We've got x, that makes 2 x's. And we have 15. So the length of the new garden is 2x plus 15. The width of the garden is x, x, and the 10. So 2x plus 10. Now, what does it equal? Well, hold your horses here. Look at here. We're going to double the area. We're going to double the area. Well, that means the new garden is 300 feet, square feet. All right. Wow. Okay, this looks like a mess. Here we go. So we're going to have to foil this. All right. Ooh, here we go. We're going to foil. 4x squared plus 20x. Again, I'm foiling. Plus 30x plus 150 equals 300. All right, combine like terms. 4x squared plus 50x plus 150 equals 300. All right, well, now I'm going to, I got to set it equal to 0. I can't solve it unless it equals 0. So I'm going to subtract 300. So 4x squared plus 50x, let's see, minus 150 equals 0. All right, wow. Okay, I'm running out of room. So I'm going to need to make a little bit more room here. So let me pause this a second and make a little bit more room. All right, now that I have a little bit more room, what I'm going to do next, okay, we haven't run across this yet, but I noticed that all of these are even numbers. So what I'm going to do is I'm going to divide by a common factor. And that common factor is 2. So I'm going to divide everything by 2. So I'm going to go over here. 4x squared plus 50x minus 150 equals 0. All right, so I'm going to divide everything by 2. So now I have 2x squared plus 25x minus 75 equals 0. All right. Well, to factor this one, we're going to use the box. Okay, back up. There we go. All right. The reason I need to use the box is because the lead coefficient on this is 2. All right, so the 2x squared goes in the top. The minus 75 goes in the bottom right corner. We're going to multiply these two together. So that's going to be negative 150. Now, factors of negative 150, that add up to 25. Okay, might be a little bit challenging, But we find out that the two numbers, okay, so the factors that multiply to 150 and add up to 25 is 30 and negative 5. Okay, let me show you. 30 times negative 5 is negative 150. 30 plus negative 5 is 25. So I'm going to put 30x in this box and negative 5x in this box. All right, now we're going to do the GCF. Okay, if this does not look familiar to you, then you probably didn't see it in intermediate algebra. It was shown in intermediate algebra. If you went to school at Heights, this was shown to you by your intermediate algebra teacher. It just might have been a while since you've seen it. All right, so now I'm going to pull out the GCF. Okay, the GCF of the top is just x. Remember, GCF stands for greatest common factor. All right, so the top two have x in common. The bottom has 30 and negative 75. They share 15, positive 15. So one of my factors is x plus 15. Okay, now I'm going to pull up. So the left two boxes have 2x in common. The right two boxes, keeping the sign closest to the edge, they have negative 5 in common. So 2x minus 5, okay, equals 0. So those are my factors. So my solutions are negative 15 and positive 5 over 2, which is the same as 2.5. Again, we cannot have a negative dimension. So that means they're going to need to add 2.5 feet to each side. So this is 2.5 feet. This is 2.5 feet. This is 2.5 feet. And this is 2.5 feet. So they added 2.5 feet to the left side, 2.5 feet to the right side, 2.5 feet to the top, 2.5 feet to the bottom to double to 300 square feet. So this is what they needed to add to each side. All right, again, ladies and gentlemen, okay, if you're confused, okay, you're not sure, watch it again. Listen very, very carefully. All right, good luck.